In modern C++, we have another kind of for loop for looping over a range or a list of values. For example, we might have an integer array called numbers. Let's initialize this to 1, 2, and 3. Now let's say we want to loop over this array and print each number on a new line. So using the for loop that you learned in the previous lesson, we can type for. First, we declare our loop variable, so int I equals 0. We're going to loop over this array while I is less than 3, which is the size of the array. And then after each repetition, we're going to increment I by 1. Now in the body of this loop, we're going to print numbers of I followed by an endl, right? Let's run the program and see what we get. So we see each number on a new line. Beautiful. Now, there is a problem in this implementation. The problem is that we have hard-coded the size of the array over here. So if tomorrow we decide to add a new number in this array, we have to remember to come back and update this number. So instead of hard-coding the size of the array, we have to calculate it dynamically. Now, in C++, we have a function that you have seen before. It's called sizeOf. If we pass our array here, it will return the number of bytes allocated by this array. So over here, we have 4 integers, and on my machine, each integer takes 4 bytes. So size of numbers is going to return 16. Now, if we get that number and divide it by size of integer, which is 4 bytes, we're going to get the number of items in this array, right? So let's divide this by size of integer. Let's run our program one more time. Okay, we get the same result. Beautiful. What if we remove one of the numbers? Let's make sure everything still works. So there you go. Beautiful. So this is our traditional for loop. Now in modern C++, we have another kind of for loop for these kind of scenarios, where we have a list of items and we want to iterate or loop over them. That is called the range-based for loop. So I'm going to type it right after this for loop so we can compare them side by side. Once again, we start with the for keyword. Now in parentheses, we declare a loop variable, but this variable is going to hold one of the items in this array in each iteration. So here we have an array of integers. So here we declare an integer called number, followed by colon, and then our array, numbers. So in each iteration, number is going to hold one of these values, okay? So now we can print the number followed by endl. So unlike the previous approach, here we are not working with an index. We are working with the actual items or the actual integers in our array. Now compare these two implementations. Obviously, you can see that the second implementation is much more compact and concise, and it gets us the same result, okay? Now, using the range-based for loop, we can also iterate over a string, because a string is a sequence or a list of characters, right? So let's take a look at an example. So I'm going to delete everything here and declare a string called name and set it to my name, Mosh Hamedani. Now, to iterate over this string, we type for. Now here we need to declare a variable that is going to hold each character in this string in each iteration. So we declare char ch in name, and then we print ch followed by an endl. Take a look. So we see each character on a new line, okay? Now here's your exercise. Given a list of temperatures, write code to calculate the average temperature. It's pretty easy. You can knock it out in a couple of minutes. All right, here's my solution. First, I'm going to declare an integer array called temperatures and initialize this to 60, 80, and 90. These numbers don't really matter. Now, to calculate the average, we need to loop over this array and add all these numbers or all these temperatures together. So we need another variable called sum for holding the sum of these temperatures. I'm going to initialize this to 0. Now, using a range-based for loop, we can easily iterate over this array. So we declare an integer called temperature. And in each iteration, this temperature is going to hold one of the values in this array, right? Now, in each iteration, we're going to take the sum and add the temperature to it. Now, we can simplify this code using the compound assignment operator that you learned about before. So we have the sum. Now we need to divide it by the total number of items in this array. So to calculate the average, we declare a variable of type double because the result can be decimal. So we call this average and set it to sum divided by. Now, to get the number of items in this array, just like before, we need to get the size of the array, so size of temperatures, and divide it by size of integer. Now, this code is getting a little bit confusing, so to improve the clarity of our code, it's better to grab this expression and store it in a separate variable called count. So let's cut this from here, declare another integer, or short is fine too, count. Okay, then we get the sum and divide it by count. Our code is more clear now, right? Now, because we're dealing with two whole numbers, the result of the division is going to be a whole number. That's not what we want. So to force the compiler to perform a decimal division, one of these numbers has to be a decimal number. So here we can change the type of sum from int to double. And the warning goes away. Then finally, let's print the average. Take a look. The average of these temperatures is 76.6. Beautiful.